Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following analytical geometry question on circle, and that entails the equation of a circle and the tangent to the circle. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. We have given a circle with the center N. The equation of the circle is x squared minus 2x plus y squared plus 2y minus 3 equals to 0. JK is a tangent at K. The first part of the question says, determine the center and the radius length of circle N. Note that the standard equation of a circle, that's the A part, we have that as x minus a all squared plus y minus b all squared equals to r squared, where my AB is the coordinate of the center of the circle whose origin is not at 0, 0, or whose center is not at the origin. And then we have a radius r. We've been given the equation of a circle to be x squared minus 2x plus y squared plus 2y minus 3 equals 0. So what I'm going to do is I'm going to complete this circle. So it's going to be in two ways, for the x and for the y. So before I do that, the first step, I'm going to move my negative 3 to the right hand side. So I have my x squared minus 2x plus y squared plus 2y equals positive 3. The next step is to complete the square. So I'm going to complete the square for x squared minus 2x and then for y squared plus 2y. So therefore, while completing the square, the first step is to make sure that the coefficient of x squared or y squared in this case is 1. And then the next step is to add the square of half the coefficient of x. So that's two steps in one. The first step will be, I have a square bracket, x squared minus 2x. Then I'm adding the square of half the coefficient. So the coefficient is negative 2, the coefficient of x, divided by 2 all squared. I'm going to close that bracket. And then I'm going to do the same on my right hand side for y squared plus 2y. And that's going to be, I have y squared plus 2y plus, then I'm adding the square of half the coefficient. The coefficient of y is 2, so I'm going to half that. It's divided by 2 all squared. Close bracket. And note that whatever you do on the left, you do on your right. So that's going to be, I'm going to move this. My 3, which is on the right hand side, plus I added half of the coefficient of x squared. And then I'm going to also add that of y. That's 2 over 2 all squared. Next step is I'm going to complete the square for my x, and that's going to be, I pick my x and then the content of the bracket. So that's going to be x. If you want to know how to complete the square, check in the comment section for links to that. So that's going to be minus 2 divided by 2 is 1, and then I have that all squared. Plus, I'm going to do the same for my y. I have my y, 2 divided by 2, that's 1, so positive 1, all squared. I've been able to complete the square on my left hand side. I'm going to simplify my right hand side. That's going to be 3 plus negative 2 divided by 2 all squared, that's 1, and then plus 1, and that will give me 5. So therefore, if I write that nicely, that's going to be x minus 1 all squared plus y plus 1 all squared equals 5. So therefore, to find the value of A and B, which is the center of the circle as noted earlier, it's going to be the center. If you look back to the diagram, center is N. So I have the coordinates of N will be 1 and -1 for Y. And the radius is going to be the square root of 5. Note that if I square the square root of 5, which will be similar to what I have here, then this value is going to be 5. So note that the radius is square root of 5. The second part of the question says, determine the coordinates of K. K is line, or that we have JK is a tangent at K. So that is where we have the tangent. So I have that as here. Note that K is lying on the x-axis, so therefore at K the coordinates will be, we don't know what the value of x is, but y is 0. So therefore substitute y equals to 0 into the original equation of the circle as shown. We have x squared minus 2x plus y squared plus 2y minus 3 equals 0. If I substitute y equals 0, what I have will be x squared minus 2x plus 0 squared is 0, and 2 times 0 is 0, minus 3 equals 0. If I simplify further, I have that as x squared minus 2x minus 3 equals 0, and solving for x, I'm going to factorize my left-hand side. That's x times x. And then I have that as -3 and plus 1. So therefore, x minus 3 equals 0. X equals positive 3. And the next value of x, or x plus 1 equals 0. X equals -1. And if you look at the position of K, it's on the negative x-axis, so therefore the coordinates of K will be, x will be -1 and the value of y is 0. The next question says, determine the equation of the tangent JK. Note that JK is a tangent, and what that means is if I draw a line from the center of the circle, that's N, to K, then I'm going to form a right angle there. So that what that means is the line NK is perpendicular to the line JK. So therefore, I already have the coordinates of K, the coordinates of K, and the coordinates of N. K is -1 and 0. I have the coordinates of N from my previous calculations. That's 1 and -1. So therefore, I'm going to use one of the rules of analytical geometry that states that if we have two lines that are perpendicular and I multiply the gradient, it's going to give me a -1. So I start by finding the gradient of MK. I have M of Kn equals the change in y divided by my change in x. I'm going to tag this x1, y1, x2, y2. So this is going to give me y2, that's -1 minus y1, 0, divided by x2, 1 minus x1, that's -1. So that's going to be -1 divided by 1 plus 1, 2. Therefore, the gradient of Kn multiplying the gradient of Jk or Kj is equal to -1, and the reason being perpendicular lines, or the line Kj is perpendicular to the line Nk. So therefore, putting in the values, I have negative, or mkj, -1/2 times mkj equals to -1. Therefore, mkj, or the gradient of kj, will be -1 divided by -1/2. That's going to give me +2. So the equation of a circle, we have that as, or equation of a straight line, y equals mx plus c, where my m is the gradient and c is the y-intercept. So if I replace the gradient m, I have y equals 2x plus c. The next step, I'm going to substitute a point on the line. I'm going to substitute the point -1, 0, that's k. Substitute k, which is 0 and -1. So therefore, I'm doing that to get the value of c. So I have 0 equals 2 times -1 plus c. So I have 0 equals -2 plus c. So therefore, the value of c equals +2. So therefore, my equation will be y equals 2x, c is 2, so that's going to be +2. So that will be the equation of the tangent jk. And the last but not the least part of the question says, determine the size of KLM. I'm going to look for that in the diagram. KLM, that's the angle shown. A relevant reason must be given. Using the tan-cut theorem, I have the tangent drawn, and I have this triangle embedded in the circle where all the corners of the triangle touches the circumference of the circle. So note that the angle, or the angle of inclination of JK as shown, will be equal to KLM. That's the tan-cut theorem. So I just need to find the angle of inclination. From the previous calculation, I was able to calculate the gradient of the line KJ. That's equal to 2. So therefore, the tan of theta, I'm going to call this theta, which is the angle of inclination, is equal to the gradient 2. So therefore, my theta is arctan. That's the second function button of your tangent, of your tan button on your calculator. Therefore, theta equals 63.43 degrees. So I can state that KLM, that's the angle, is equal to 63.43 degrees. The reason being that's tan-cut theorem. Thanks for watching. Bye.